All right, so there's a couple of forms, right? We've been looking at vertex form, which is very useful because you know where the vertex is. You also have the A value, so you have the direction of opening and the vertical stretch factor, which makes it very easy to sketch, right? Or very easy, given an equation in vertex form, given a graph, to figure out the vertex form equation. But what if you're given a standard form equation? Y equals ax squared plus bx plus c. What we want to do is convert that to vertex form. What do you get out of here? So what information is in standard form? Looking at this equation, you can tell what? The A value, which is the same, okay? So you've got direction of opening and vertical stretch, and what else? The y-intercept, okay? So, can you plot something if you know the y-intercept and which way it opens and the stretch factor? No. I can plot 20,000 different graphs with the same y-intercept, so you can't. So, but if we can convert it from this form to this, then we can plot it, right? And we can also tell where the maximum is. Do you know where the maximum is or the minimum? No, you just know if it has one and which one it is. Okay, so there's not much information here, right? Really just the y-intercept. Okay, so nothing here, right? Converting from vertex form to standard form. In order to convert from vertex form to standard form, so we're just going to go the other way first, which is actually pretty easy. We first need to expand the square of a binomial, x minus p quantity squared. Examine the following to find a shortcut. Okay, so x plus 5 squared. What does that mean? It means you multiply x plus 5 by itself. When you're multiplying binomials, how many products will you get? You're going to get 4 products, right? Which will collect into 3 terms. But you're going to get 4 products, right? Which will collect into 3 terms. But you're going to get 4 products. And I emphasize this because people take something like this and it becomes x squared plus 25. At which point you're losing 3 marks on the question if that's what it out of. Okay? So that is my unforgivable error. You square a binomial and get 2 terms out of it, you will get 0 marks on the question. Okay? It could be out of 5 marks. I don't care. You cannot square a binomial and end up with 2 terms because you're going to get 4 products which will likely collect into 3 terms. But never, ever, ever will you get 2 terms from squaring a binomial. Okay, how do you get 2 terms? Difference of squares. X plus 5 times x minus 5 will give you 4 products, which will collect into 2 terms. But you're always going to get 4 products, right? Okay. So what's the shortcut? How do we just look at this and write this down? How do you get x squared? Square the x. How do you get 25? Square the 5. How do you get plus 10?
Square the 2 5x's.
Yeah. So you double, right? And here it's minus. So here's how you square it in short form, right? So you don't have to write before. You could just write the final answer. You take the square of this term, x squared. You take this sign, plus. You take this times this, 5x, and you double it, which gives you 10x. And then you take a plus, because it's always a plus, and you square the last term, 25. Okay, so that's short form. If that doesn't work for you, 4 products collected into 3 terms. Okay. So you take the first term, square it. Take this sign, minus. You take 7 times x, 7x, you double it. And you add the square of the last term. Right? Why are you doubling? What's a mistake here? This is wrong. That's a minus. Okay? I don't know if it's fixed on yours, hopefully. Good. Squaring a binomial results in a perfect square trinomial. So these guys here are called perfect square trinomials. To get the 3 terms of the perfect square trinomial, you square the first term. So we just went through this. You multiply the 2 terms of the binomial and then double the product. and you square the last term of the binomial, which will always result in a positive, right? Always positive. Because if it's negative, you got a negative times a negative. And if it's positive, you have a positive. All right, go ahead, you do these two. And then look up and say, huzzah. Or, what did I do wrong? What did you do wrong? Good? Okay, still working on it? Finish up? Okay, gotta get, it's gotta be crisp. It's crisp. Right? You gotta know this, so you can't be sitting on a test thinking about, how do I square a binomial? You know, you can, but you don't want to be spending that time, right? You want to be good at that skill, so you look at x plus 8 quantity squared, and you write x squared plus 16x plus 64, and then you don't think about it. Convert each of the following to standard form. Okay, so we're actually going standard form. So what are you going to do?
Write the standard form.
Write this 10. So we're going to square this, right? It's 3 times the square of this, so we're going to square this. Okay, so order of operations says you got to square first, right? You got to do the power first. Okay. Then we're going to multiply that by 3. Okay, we still got the minus 17 hanging there, and then we're going to subtract the 17. Is that like 91? Okay, so step 1, square the binomial. Multiply by any number that's out in front, add on or subtract the constant term. Okay, give the next one a shot. Right, while you're doing it, I'll do it. You can look up. Okay, so we square the binomial, right? We're going to use our newfound binomial squaring skills.
It would be negative now.
Oh, it's a negative a half. Didn't see the negative. All right, well, that's going to change everything then. Negative. Minus 4x minus 8. Okay, better? Questions on the procedure? Okay, so converting vertex form to standard form, easy peasy, right? Square a binomial, multiply by the constant out front, and collect the constant. In order to convert from standard form to vertex form, we need to express a perfect square trinomial as the square of a binomial, right? Looking back, right? In vertex form, you have the square of a binomial, right? What was that? Well, that was this. X squared plus 8x plus 16 becomes x plus 4 quantity squared, right? That's just factoring this. So we need a perfect square trinomial, which is something whose factor is the square of a binomial, right? So that's what we're aiming for. I got to get one of those somehow. In order to do this, we need to determine the third term that completes a perfect square trinomial. So really what we're kind of doing is working this backwards, right? Examine the first two perfect square trinomials in the following table to determine the relationship between the coefficient of x and the constant term. Also, determine the relationship between the perfect square trinomial and the binomial for which it's a square. Use your conclusions to complete the last row of the table. Okay, so if I have, well, a moment to look at that. We have x squared plus 10x plus 25, that's x plus 5 quantity squared. X squared plus 16x plus 64 is x plus 8 quantity squared. X squared minus 24x
Plus 144.
plus 144, which is x minus 12. So, how'd you figure those out?
Because negative 24 divided by 2 is 12. Negative 12.
Yeah. So basically, what do we need to do? We need to take half of the middle term, right? We have the middle term. Half of negative 24 is negative 12. Okay? I just prefer to think of half of 24 as 12 and just remember that I'm dealing with a minus sign. Okay? Half 24 is 12, and what's the last term? 12 squared, which gives us the 144. Okay? So to determine the constant term that completes a perfect square trinomial, we blank the coefficient of x by blank, and then blank the result. So we divide the coefficient of x by 2, and then square the result. Use your relationship to determine the constant term that makes each of the following a perfect square trinomial, and then express as the square of a binomial. Mark, it's it. Go. Use fractions, 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 right? Not decimals. If need be, fractions. So how'd it go? How did it go? Goes okay? Yeah. Okay. So I don't really worry about the sign too much. I just know that if there's a minus sign there, then there's going to be a minus sign in my binomial. And if there's a plus sign, there'll be a plus sign. Okay. And what the only maybe challenging thing here was, oh, what do I do with 7? It's 7 halves. 7 halves squared is 49 over 4.
In a test, I assume you'd rather it as a fraction than a decimal.
Yeah, I think that would be better. But it's sometimes the reason, yeah, I prefer fractions. Yeah.
Okay.
Go with fractions. I'm going to do all the examples with fractions. Convert each of the following to vertex form. Go ahead, no. All right, so here's the procedure. Now you got to watch this because when I do this, I mean, the nice thing about the recording is we're going to bounce back and forth between two lines, right? Which on your notes are static. So you're going to look at your notes and go, how did that happen? Okay, if you want to know how that happened, you can look up here, right? Because we're going to work on one line and then work our way back. So we're going to kind of do it that way, right? Which on paper doesn't translate, right? It's hard to sort of show the sequence of stuff that happened. So, we're going to do like a bunch of them. So, hopefully it'll become clear as we do it. Wait for this to disappear and then get ourselves a thick line. Yeah, I know. Right? It's like, there we go. Okay, so here's what we're going to do. We put down a set of brackets. So I'm going to write it like this. I wish I could move it over a bit. Clean that up. So I'm going to leave a blank at the end, right? Okay. Now I want that set of brackets to be a perfect square trinomial, right? So what's it going to be the square of? x plus 4, right? So what goes here to make it a perfect square trinomial? Plus 16, right? Now, if I add 16 to this line, I've changed it, so what else do I have to do? You add 16 and you subtract 16. Okay, so what's minus 5 minus 16? Boom, done. 2 lines. Okay, so you isolate the x squared and the x term, right? You then write your perfect square trinomial on the next line. So what is it? Well, it's x plus 4 squared. Okay, so what has to go up in the first line then? Well, we need a plus 16, right? Because we need this to be a perfect square trinomial. Now, is this line here equal to this line here? Okay, if you remove the brackets and collect terms, is this line this line? It is, right? Because what do you got? You got a plus 16 and a minus 16. Okay, good. That's the method. But what if there's like a 2 in front? Put it outside. Okay, so if there's a number in front, we factor that number out of the first 2 terms. Right? Because we need a perfect square trinomial, right? Which has to be of the form x plus or x minus. We can't have a 2x, right? You try and square 2x, you're going to get a 4x squared. Okay, so we go down here, we go y equals 2, x minus, so what do I do with x squared minus 6x to make it a perfect square trinomial? Yeah, I subtract 3, right? Minus 3 squared. Okay, now you take that, so let's complete this. So it's x squared minus 6x plus 9. So now what? Do I subtract 9 out here? No, what do? I subtract 18, right? So it's a 9 in here, right? But 2, this is really 2x squared minus 12x. This is going to be plus 18. So we have to subtract 18. And then what's 7 minus 18? Negative 11. Okay, work this backwards, right? What are you going to do with this? You're going to square it, which will give you this. Then you're going to expand. 2x squared minus 12x plus 18 minus 18 plus 7. We got back to the original. Okay? So, all happens on 2 lines. Now, you may see ways of doing it where you've got more than 2. I don't see the point in that. Okay? I'd rather just keep it to the 2 lines, but you do have to work back and forth, right? You write this down, you go to here, I got my perfect square, so I need this. Oh, wait, the 2 in front. So, what happens if there's a negative in front? Goes outside. So, we have to factor out the negative, right? Negative bracket. Now it's going to change the sign of the first 2 terms. So the first term becomes positive x squared, second term becomes minus 7x. Negative x minus what? 7 over 2. Right? Got to take half of squared. Okay, now we move back up. What goes back up? Plus 49 over 4. And what do I do on the end here? Got to add, right? So what I really want to do, and sometimes the method you see is they'll write this down. It's x squared minus 6x plus 9 minus 9 in the brackets, and then they'll do the 2 with it. We say, oh, there's a negative out here, right? So it should be minus 4. Oh, it's going to become plus 49 over. Just the same way this became minus 18, this becomes minus 49 over, or sorry, plus 49 over 4. Okay, make sense? Right? Because we're really what we're doing is, you know, and the thing we don't show you is that it's really like x squared minus 6x plus 9 minus 9 with the 2 in front. You know, then you move that out and it becomes this. So I just, you know, kind of cut to the chase, right? Like why? I don't think we need to show all that extra. And what do we end up with out here then, right? It's going to be plus 33 over 4. Right, so going over here, that's minus 16 over 4 plus 49 over 4. Yep.
Will we lose marks next time if we don't use fractions?
Yeah? Yeah, I'll just mark it wrong. No, not an issue. Okay. I don't like decimals, especially with the 33 over 4 bit, right? Now it's, yeah.
Do we need to show, like, when you're marking our test, like, that we added the fractions, or can we just put 33?
No. Plus, what you see, I'm just showing that for people who are going, where did the 33 over 4 come from? Right? We got to change the 4 to 16 over 4, right? We need a common denominator. You don't need to show that. Okay? Now, look, you may use your calculator to convert it to a fraction for you, okay? So feel free in your head, wherever in your calculator, to use decimals and then convert them to fractions before you actually write them. So to convert a decimal to a fraction, if you went minus 4 plus 40, go ahead, get your calculators out. Go negative 4 plus 49 divided by 4, hit enter. Okay, you're going to see 12.25. Hit the math key and hit enter twice. And now you're going to see 33 over 4. Oh, sorry. 8.25. And now you're going to see 33 over 4. Yeah? Okay, so math enter. What math does takes you to the math menu. The first thing in the math menu is to frac, right? Convert this to a fraction. So when you hit enter, in your calculator it just says to frac, and when you hit enter again, it actually does that, and that's what does the conversion. Okay, so it's not magic. It's just math enter is just math converted to a fraction. Here's your fraction. Okay. Yeah. Some things it can't. Okay, what comes next? X squared. Minus 10 over 3. Yeah. Here's why you can't use decimals. What are you going to do with 10 thirds? Ah, it's 3.3333333. What's half of 3.333333333 for you can't do it, right? What's half of 10 thirds? 5 thirds. Yeah, that you can do, and it's exact. You know, so with halves, let me take marks off if you use quarters and halves where they're exact. No, you take marks off if you do thirds and you try and write it as like 3.3 whatever. Of course. I mean, what's 3.3 repeating divided by 2? You know, and then you're going to square that, right? No. Right? That's not going to work. So negative 3x minus, what's half of 10 thirds? 5 thirds. What's 5 thirds squared? Just go with 25 over 9, right? 5 squared is 25. Okay, if I add 25 over 9, I have to subtract 25 over 9, but I'm going to multiply it by negative 3 to bring it out, right? So really there's a minus 25 over 9 in here. Multiply that by negative 3 and it becomes what? Well, let's go with plus 25 over 3. The 3 goes into the 9, right? Negative times a negative will be positive, so it's positive 25 over 3. Okay, so what goes here? Feel free to use your calculator. It'll convert you to fractions. Okay, 19 over 3, yeah. Okay, everybody following? If you're not, say something. You know, once you practice this on your own, right? Like you got to do 10 or 15 of these, and it'll be pretty much second nature, right? But you got to do 10 or 15 of these. You can't just watch this and then say, I can do that, and I'll just, you know, I'll do that on the test. Because on the test, you'll sit there and go, what the heck do I do now? Like, I don't understand, man. I'm not sure where I go. All right, and what am I gonna do with this? Move that there. Okay, you try the next one. All right, so let's see if. When you do it, just multiply this back in, right? A half x squared plus 3x, right? So if you wrote down like 3 halves there, that's not it, because that would give you 3/4, right? So you think, I'm dividing by a half. I hate that, right? We're going to divide everything by a half. Instead, let's multiply by 2. 2 times 3 is 6, right? Check this out. Does this match this? Half x squared plus 3x. Yeah, okay, good, that matches. Yes, no, maybe so. Not really, it's just yes or no. One of these times I'm going to try and make mistakes. Well, I'm going to try.
Shouldn't you multiply 3 by a half?
Yeah, 3/2.
What's a half times 6?
But,
What's a half times 6?
okay,
So like why is it x squared plus 6x?
yeah,
Okay, what's a half times x squared? 1/2 x squared. What's a half times 6x? Well, what's in the original question? It's plus 3x, right? Okay. That's the big point, right? That's the confusing point, right? What did you have? 3 halves or something? Or? Yeah. What's a half times 3 halves? 3/4. There's no 3/4 in there. Okay. So look, big point, right? Check it out. When you write, so forget the rest of this is here, right? This just remember that we start off with these two, right? Negative 3x squared plus 10/3 times 3 is plus 10. So when you factor that half out, multiply it in. Half x squared plus 3/4 x. Oh no, it's not 3/2, right? It's 3 divided by 1/2, which is 3 times 2, which is 6, right? Or it's a half of what gives me 3. That's the easier way to think about it. It's like, okay, what am I going to write here? Well, half of what's going to give me 3? Half of 6. Okay, I'm going to write a 6 there.
But then why did you get -9/2 instead of -18?
Okay, so I'm multiplying it by a half. Right? Look, why did we get 25/3? We had to multiply by -3. I'm multiplying by this. I'm not dividing by it. Right? I'm dividing by it to go from here to here. When this comes, remember, there's a -9 in there, right? +9 -9. Bring it out. It's a half times -9. It's a -9/2. Okay. We good with that one? Is it right? I don't know. Maybe I made a mistake. We could expand it back out, right? Let's expand it out. We got room. So y equals 1/2. Okay, it's over now. Do not do this on the test to go re-expand it, right? I mean, you can do that to check. Use your own paper, use graph, whatever. So it's a half. This is x squared plus 6x plus 9 minus 21/2. So that's 1/2 x squared plus 3x plus 9 halves minus 21/2. So it's a half x squared plus 3x. So that's going to be minus 12/2, which is -6. All right, so I think that's good, right? So if you want to expand it back out to check it, by all means, but don't do it on the piece of paper that I'm going to be looking at. Or if you do, just cross it out. Okay? Don't leave it as part of the solution, because you're going to lose a mark.
I still don't understand why is it -9/2, not positive.
Okay. So you could write it like this, right? So you could say in the brackets, what am I going to do, right? I got the 3, I'm going to have to add 9, but I better subtract 9. So is this line here the same as this? Okay, so that's gone basically. So yeah, the same, right? You look at it, you gotta say, yeah, okay, they're the same. Okay? This, yes, no, what? Yeah, I'm good.
So
Or,
I'm tired.
okay. I gotta take this out. When I take it out, it's gotta be multiplied by the half. It's not really a negative 9, it's really negative 9 halves. Okay? So what do we do instead? We just write it like this, and then take it out in one step. Okay? Okay, so you're just thinking, I'm adding 9, I got to subtract 9. It's like here, I'm adding 25 over 9. I need to subtract 25 over 9, but I got to multiply it by negative 3, so it's going to become a plus 75 over 9, or 25 thirds, right? So plus 25 thirds. Oh, God, decimals. What's 6 divided by 1.2? 5, yeah. So it's 1.2. We're going to have to live with the decimal this time, right? But we won't do decimals if we can help it. X squared minus 5. I'm going to double check, right? 1.2 times 5. Do that in your calculator. 1.2 times 5 is. Right? You're going to go 6 divided by 1.2. Actually, for this one, you can go 3 divided by a half, right? Or 3 divided by 0.5, and then you'll see a 6. Okay. All right, so we need 1.2 x minus what? 5 halves squared, right? Half the middle term. Okay. What's the square of 5 halves? 25 over 4, and we're done, right? Plus 0, yeah, plus 0. There's nothing out here. Oh no, we got to what? So we got to subtract, and we got what's that? I need a calculator now. So what's 1.2 times 25 over 4? 7.5? That's good. It's called 15 over 2. Minus 15 over 2. Okay? You must practice this, right? And it must be fix-it, focus, practice. You got to do it, and then you got to check it. Okay? Now you're like, you just check in the back of the book. We could check by just expanding this out, right? But that's a pain, right? So just look in the book, make sure that your answer matches. Oops, is that it? All right. So practice, practice, practice. Do 20 or 30 of these. I don't know how many are in the homework, but do, go beyond if you need to, right? I mean, if you do what's in the homework, you get it all right, you're probably good. And, if there's still time, we got a lot of time left, so if there's still time, do some more. Okay? Doesn't hurt to practice this, right? You got to drill it in. And do this as well. If you don't do them all, that's fine. Go back and do some of them tomorrow, and then do a couple of days later, right? Because we got a quiz Wednesday, right?
Yeah.
Yeah. Okay. So you're gonna want to, there's gonna be some of this on the quiz, right? There'll be this converting. There might not be much of what we do tomorrow on the quiz because it's not really fair, right? So when we quiz, we tend not to quiz on material that's covered the day before.
Well, it says the quiz is on what we covered the day before.
Except in this case, where we are covering. No.
This is applications.
Yeah, you're right. And then it's continuing on. Okay. What kind of situation? Yeah, I will be doing some. Okay.
Oh.
So,
Okay.
yeah. Well, because tomorrow we're going to do some of that. What kind of situations to describe? There's only, 6 questions or less. You'll have some time to work in class on tomorrow's lesson, so it is fair to quiz you on. Right. Then we're going to do the quiz and then continue on, right?
Oh, I thought that's what the quiz was on.
No. The quiz is on everything above. Okay. So also including some applications. Okay. But this will be on the quiz, so you want to do some of these, tonight, but you want to do some tomorrow night so that you're ready for the quiz.